All right, so we're going to have an example where there's an uncommon denominator, and it's a binomial. We're literally going to take this binomial, that's the denominator on the right side, and multiply it as a form of 1 on the left side. Then I'm going to take this denominator here on the left side and multiply it as a form of 1 on the right side. So when I distribute up top, I get 12x minus 30. And I'm a fan of leaving the denominator like this. You do not need to FOIL it out. If you were to FOIL it out, you're not wrong. But I think it's easier just to leave it like that, and I would encourage you to do so. On top, I distribute 15x minus 10, and we're left with 2x minus 5 over 3x minus 2. And when I'm done adding, we keep that denominator. Okay? And I combine 12x and 15x is 27x. Negative 30 and negative 10 is negative 40. And this would be my answer. So that should be your answer in terms of adding two fractions with an unlike denominator. I'm going to put parentheses around here as I should. So when we subtract, similar to addition, we need a common denominator. So I got to force that in with 2x plus 1 over 2x plus 1. And I'll put parentheses here. And then 3x minus 2 over 3x minus 2. And I put my parentheses there. I'm going to distribute up top. I'm going to get 8x plus 4 over 2x plus 1, 3x minus 2, minus 15x minus 10 over 2x plus 1, 3x minus 2. So I take this 5 and I distribute it, and I get 15x minus 10. Now here's the trick with subtraction that usually throws people off. Obviously the denominator is common, so we keep it. 8x minus 15x is negative 7x. I can't stress this enough. This negative has to go to both terms. The common mistake is people do 4 minus 10, they go negative 6. No. 4 minus a negative 10, it's a plus 14. Now, one other piece here. If I take a 7 out, or a negative 7 out of here, I'd be left with x minus 2. If there was an x minus 2 on the bottom, then I could simplify even more. That's why I'm not a big fan of you foiling this out. Unfortunately, the x minus 2 doesn't really cancel anything out, so I would leave it like this. You could see this answer, though, written as this as well, just so you're aware of it. Someone could write it like this. So I just want you to make sure you're aware either one works. I would accept this one right here, though, on the left. All right, so here, my denominators are representing x minus 2 over x minus 2. And then 2x minus 3 over a 2x minus 3. On top, I'm getting 8x. I'm sorry, not 8x. We're getting a 4x minus 8 over x minus 2, 2x minus 3. Plus, we have a 4x minus 6 over x minus 2, 2x minus 3. And when we add, right away I can write down the common denominator. That's always going to be consistent. 4x and 4x is 8x. Negative 8, negative 6 is negative 14. There's my answer. Now with the subtraction, that's where I need to be a little more careful. All right, with subtraction, we begin the same way. Okay. We have to force that common denominator. Now up top, I get 10x plus 15 over 2x plus 3, 3x minus 5, minus 12x minus 20 over 2x plus 3, 3x minus 5. And that equals, we have a common denominator, 2x plus 3, 3x minus 5. On the top, 10x minus 12x, negative 2x. 15 minus a negative 20 is plus 35. And that's our answer. The last one presents the same way. 3x minus 4 over 3x minus 4. 2x plus 7 over 2x plus 7. So we have 18x minus 24 over 3x minus 4, 2x plus 7. Minus 6x plus 21, 3x minus 4, 2x plus 7. That denominator is going to be 3x plus 4 over 2x plus 7. That stays. Oh, I'm sorry, 3x minus. Don't change that sign. 3x minus 4. Okay. Now on top, 18x minus 6x, that's 12x. Negative 24 minus 21, that's a negative 45. And that's my answer. Any questions with that? So whenever we have trinomials in the fractions, here's what I want to do. I want to factor the bottom. Now, this is where we can legally cheat here a little bit too. If I FOIL these, I get 2x plus 1 times x plus 5, and I get x plus 4 times x plus 5. What's common in both denominators? X plus 5. So what I have to do is take what's not common in both denominators and force it in. You're not wrong to try and multiply both denominators, but you're going to drive yourself nuts. So here, I don't have 2x plus 1, or I should say this. I have 2x plus 1 in this denominator, but not this one. So I'm going to force 2x plus 1 in over here. I just have a longer common denominator. And it might be a little annoying to write down. I don't care. You got to write the entire denominator down. On this one, x plus 4, x plus 5, 2x plus 1. On top, we have 4x plus 16, 6x plus 3. And then the numerator is 10x plus 19 over x plus 4, 2x plus 1, x plus 5. That's my answer. So we're going to factor first. And understand, I'm probably not giving you a problem where there's not at least one common factor. So you've got to factor correctly. That does matter here. You factor incorrectly, you throw your whole problem off. The x plus 2 is in both denominators. So I don't need to force it in either one. But over here, I need to force 2x minus 5 into this one. And over here, I need to force x minus 9 into this one. Okay? So now, 2x minus 5, x minus 9, x plus 2. Minus 2x minus 5, x plus 2, x minus 9. If the order's not the same, that's okay. But we have the same three terms in both denominators. Now I distribute up top. 6x minus 15 minus a 4x minus 36. And now I got to be careful with my subtraction. My common denominator stays 2x minus 5, x minus 9, x plus 2. 6x minus 4x is 2x. Negative 15 minus a negative 36 makes that 36 positive. 36 minus 15 is 19. So this is my answer.